Thank you. And speaking of the talk at Cambridge in December, I'm just assuming all of you have either watched that talk or read all the slides, so I don't actually have to explain what this two-secret key derivation is, and I can just talk about how we communicate this to users, right? Yeah, sure. Okay, so two of the three J's are here.
Jesse, please stand up.
Right here, I'm wearing the same dress.
Jesse's her reflects on Twitter.
Yes, Julie is not here. That's me at the end, and we are being protected by Umbrella Bear, a bit of an inside joke. Okay, anyway, so two-secret key derivation. We've been struggling with names for this thing, but this is the flavor of the week. Basically, what we're doing is in deriving the keys that are used for both authenticating with the 1Password server, now that we've actually have started running a service, and the keys that are used to decrypt the key encryption key that's used for encrypting your private key from your personal key set. That's way too many keys. So in deriving the keys that you actually need to unlock stuff, we take two user secrets, a master password and something that we've called an account key, and I have no idea why we call it that. So a master password is something that's more or less created by the user. It's stored only in the user's head, which makes it difficult to steal. I mean, torture's one way, but it is, it's created by, it's a human-created password. They need to remember it. They need to type it. So it is not so difficult to guess. Now, the account key is created randomly by the client, 128 bits. It is stored only on the user's device. It is possible to steal because it's stored on the user's device before they actually get their keys for encrypting their data, and it's pretty much impossible to guess. Now, the reason for this is that we don't want to store hashes that, if stolen, could be used in any kind of offline attack. That is the goal of this thing. What we store on the server, as I said, until recently, we never touched any user data whatsoever. And we liked that, and there were reasons for that. So we don't want to have anything worth stealing, anything that we could work on cracking if we were compelled or just decided to turn evil. No, it's not going to happen. Anyway, so by blending in this other high entropy user secret, this account key, then what we're storing server side is just basically uncrackable. Now, it's not actually a hash, it's an SRP verifier, but the principle still applies. Okay. Now, I said in Cambridge, I talked about the technology, the key derivation, all of that stuff. My concern here is we are presenting a new kind of secret to users. And we kind of hope that they behave in ways that help their security instead of harm their own interests. Now, so we've got this new kind of secret. It's unfamiliar. So the questions are, how do we get users to treat it properly? How can we help users not to lose it? Because if they lose, if they forget their master password or they lose their account key, that's it. There's no way to derive those keys that are used as key encryption keys. So now we've added a new way that people can get totally locked out of their data by losing their account keys. So it's sort of the user, it's the helping the user, or what we attempt to do, that is really the topic of this talk. Okay, so Chain of the Psycho Dog. She's really sweet, except for when she isn't. Catches frisbees, balls. We have no idea who trained her to do this. But anyway, so she's going to be our team leader. And so what you're going to see is a video that shows a first sign in and a first sign up for 1Password for Teams. And so we're just going to go through a lot of steps here. But I think that, so we'll see her do lots of things. And okay, so here's a video. Sorry, Chain of the Psycho Dog. This is Morgan, the other member of the family, and yeah, she's the sane one. Okay, so although we're going to talk about teams, she's going to create a family because the control panel and screens are a little simpler for those. Okay, so go through a normal sign up. She selects a family name, and she has to give her email address. And I decided not to expose her real email address, and I was too lazy to set up a special account, so there we go. And so she'll be given a URL based on that name, and there we go. She gets told that she'll get some email. There's her email. Real name. And this, by the way, is me speeding up the video because I type really slowly, but Chaina types even slower. Okay, first presentation of 2 secrets. Protect your data. And now you are given your account key. Now the first part of it is non-secret information, but the bulk of it is secret. So there's actually account identifier at the beginning of it. And so it was selectable. You saw a copy operation. She saved it someplace. Okay. Now, oh, wow, this is going way too fast.
Faster.
Okay. But as you saw, there was actually a Diceware-like generator to offer people help in choosing master passwords. She practices that. Oops, she typed it in wrong because she thought it was cake instead of cape as the last word. There we go. And now we are generating public-private key pairs and a bunch of other stuff. And her first task she's given is to save her emergency kit. The emergency kit contains all the non-secret information, her account key, and a nice space to actually write in your master password and a QR code that we'll get to later. You're encouraged to write down your master password, put this piece of paper in someplace safe. Okay, let's just set up stuff for the account. Oh, well, they're dogs, Okay. Okay, so just so that we have some data to look at, Chaina creates some data. Rabbits are faster than they look. As much as I hate to say it, we may need to cooperate instead of compete. Yay, oops, but she saved this to her personal vault. This is something that should be shared with every member of the family. So 1Password has these different vaults with different properties. So she's now put that into the shared vault. OK, so that was a lot that we've seen there. Because this first run through and then also adding data is a bit much. But this means that at the moment, the only place she has her account key is in that emergency kit that we hope that she saved, and in the local storage of the browser that she used for doing this. And remember, the account key is absolutely necessary for deriving these keys. So what we would like her to do, and for other reasons, we'd prefer her to be using a native client instead of the web client, because then we don't have to be entirely depending on TLS for the overall security. So we would like to encourage her to get this working in 1Password on different clients. So the next video, we're going to see her set this up in 1Password for Mac. So she's going to go to Preferences. She's going to select to add a new team. She's first going to do it the hard way. She's going to give up on doing it the hard way. She's going to do it the easy way. And then we'll see that she has the vaults from her team. So she's joining a team using 1Password for Mac. She can enter it manually, which means the account key, the email address, the URL, and the master password. That's not anything that any human or canine should ever have to type. So we've got this scanning a QR code. Here's a handy copy from her emergency kit. And boom, everything is there except the master password, which she types in. And now this instance of 1Password for Mac on this machine has that team data, and we see within 1Password her secure note about strategy. So now this is stored. Again, it's unencrypted, but it's stored by the account key is now stored by the client. OK, we do need to add more people to this, more dogs to this family. We're going to add Morgan. And that is going to look like this. So first, Chaina's going to log in. Because we're switching back and forth between Chaina and Morgan, you get one of the dogs showing who's actually the one doing stuff now. Also, Chaina uses Chrome, Morgan uses Safari. So Chaina sends an invite. And she gets a list of family members, including those pending invites. And Morgan gets email. Rabbit Hunters is using 1Password. Chaina the Psycho Dog wants you to join Rabbit Hunters. She clicked the link. She's now given this sign-up stuff, introduced to the two keys. I didn't see her select that account key, even though she pressed I've got it safe. OK, and she types in, she creates a master password, and I'll write which was a wonderful master password of ABC123ABC. Oh, look, save your emergency kit. Remind me later. OK, now there's a little bit of back and forth because because Morgan's keys are generated by Morgan's client when she first signs up, for the public key to get to the team administrator. Anyway, Chaina has to go through this step. For the user, it's just confirming. What it actually is doing is it is encrypting the vault key for the shared key with Chaina's public key. Anyway, now Morgan can enter in some very precious data that must never, ever be lost. And as you see, she can actually get what's in the shared vault as well, because the key to that vault has been encrypted with her public key. And there we go. OK, so now, we were really, really scared when we thought of this notion of account key. We just thought it's way too easy for people to get themselves locked out. But we, Agile Bits, do not want to have the power or responsibility of doing actual recovery for people who have lost their account keys or forgotten their master passwords. We shouldn't have the power, and we shouldn't have to be sitting there trying to decide whether some request is genuine from the real owner. So what we've done instead is we have given the family organizers or team owners that power. So every time a vault is created by any user within a team or within a family, the keys to that particular vault get encrypted with the public keys of the organizer. But the organizer may not actually have access to the actual encrypted data. That's done through normal kind of access control sorts of stuff from our server. So they don't have access to the data, but they do have the keys for it. So Chaina actually has the keys to Morgan's personal vault, but Chaina does not have the authority to get the encrypted data that is Chaina's personal vault. OK, so here we go with recovery. Morgan, having trashed her Safari installation, has lost her account key and thus lost her access to the secret plans. In an act of desperation, she sends an out-of-band message to Chaina via Droid. Fortunately for our heroes, the organizer of the team has access to all the vault keys, blah, 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 blah. OK, so now, Chaina's gotten this out-of-band message, which obviously I'm not showing. She goes into the admin console, and she sees Morgan here. And she clicks on a begin recovery button. And that really just sets Morgan's account into a particular state and sends email to Morgan about the road to recovery. And effectively, Morgan is creating a new account, but it's with her old email address and identifying information. She gets a new account key. And look, she saved it this time. And she chooses a master password. And so now a new public key pair has been generated and created for her, but you still can't get in until the team owner confirms her recovery or completes the recovery. And this is because it's the completing the recovery in which the new owner sends the appropriate vault keys or encrypts the appropriate vault keys with Morgan's new public key. And so now back in, she gets some tips to not have to go through this again. Save your emergency kit. Write down your master password. Join things in new clients. Now, so one of these things with these emergency kits and these account keys is it's actually the user's responsibility to get the account key from client to client. Okay, but I'm. It's not handled by us. It's what the QR code is for. So they can either manually type it in. And so here you'll see her setting it up in within 1Password on an iPhone, add account, scan QR code, and here, when you're actually logged in on the web, the Get the Apps link includes the QR code. It really scans fast. I did not speed that one up. Everything but the master password is filled in. Here she types in her brilliant master password. And the server's unreachable because all this demo construction was done on b5local.com instead of actually our real server. So it was just localhost on that thing. OK, and now it's time for a nap. And now, oh, right, I tried to show the QR code scanning a little slower. OK, I'm not really an expert on iMovie, in case you didn't notice. OK, so the questions that we have is, will our users understand that the account key is a secret? They're not going to be reading everything on those pages. Will they understand that it is their secret? So remember, when you're given a license code, for example, when you're given a license code, that's actually a secret that matters to the software vendor. It doesn't hurt you if that secret, if a license code you're given by the vendor leaks. But this is a secret that they need to protect for their interests. And is there more that we can do to prevent the risk of catastrophic data loss? Now, we haven't actually counted, but so far, we're actually doing pretty well from what we get into customer support. The people who are losing account keys are people who are just testing things out of the free system, who don't actually have, who actually haven't put data into the system. So the overwhelming majority of I'm locked out, help me, and we have to say tough, have been harmless so far. We also find that almost all of them are from people who've only used the web client. So we really are, I mean, there are other reasons as well, but we're really trying to push people to use the native apps. But we see this new kind of secret that we're asking people to deal with as quite possibly as at least one of the most difficult problems or challenges that we face as we've rolled out this 1Password service as opposed to just the local apps. And you know, we like to think that we try to make it easier for people to behave securely, you know, and so usable security is central to what we do throughout, but we face tough questions with this. So, and that's where I'm going to leave it.
Jeff is an expert at asking questions at PasswordsCon. So now I'm hoping there are people in the audience who have questions for Jeff.
Jeff, here. Would it work if you have a company with 20 or 100,000 people and that many accounts? Would this work with them, or do you have any experience? Do you know how that would
20,
go?
I mean, it certainly works with 20. It works with hundreds.
Are you interested in a new customer with 100,000 users? That's the question. It's a pretty big license.
Yeah, no. Yes, it'll work just fine.
He's improving, Jesse. He really is improving.
I'm not one of the sales people, you know? I mean, the line, of course, is we're all in sales.
The line is, it scales well with proper policy.
Okay.
User focus.
Okay, so I don't know what the largest company we have is, but thousands we know works. And it should scale very nicely. So it's built to do that.
Hey, I was going to ask, have you had any feedback from users who are surprised that they're under this hierarchy? So you have a hierarchy of a team owner, and then these users who can effectively be overridden by whoever's above them.
Yeah, we haven't actually, so we haven't actually had reports from users, from sort of individual non-team owners and managers saying, wait, I didn't know that my team owner had all this power. But just because we haven't had that yet doesn't mean it isn't something that we're worrying about. I don't know if I got the negatives in there. This is a question that bothers us. So is it clear to Morgan that Chaina has these powers? Now, cryptographically, Chaina, the team owner, has everything. But we also have access control mechanisms so that Chaina is not actually seeing the data, is not getting the data to decrypt from Morgan's vault. Obviously, we'd prefer to have all of these assurances done completely cryptographically instead of having to rely on authentication and access control, but we do have that. But in principle, it would be possible for Chaina to, let's say, get the cached data off of Morgan's computer. Chaina would have to be digging into, because of course the keys that Chaina has access to aren't actually exposed to her in the UI. She'd have to do some digging to get them. Her client has them. That is a line of attack, but there is some confusion. One of the problems, if I may go on a little bit more about this, one of the problems we face is when somebody leaves a company, is their personal vault theirs or is it the company's? And each organization has a different view. And so we are actually working on trying to, we're working on trying to have a way so that if an organization says the stuff in the personal vault is the person's personal thing, that data can be transferred to a personal account for somebody who is leaving a team. But this is a work in progress. But yes, these are difficult issues. Our view was to try to leave it up to the organizations, but we really can't. We have to enable the organizations to do what makes sense for them.
Yeah, I have a question. I want to make sure I understand how you're generating the KEK. Are you actually using the account key plus the master key in like a secret sharing scheme or something to get that? Or are you rather using the account key initially to authenticate and like pinning that somehow?
Okay, secret sharing would be really cool, and that was the original goal. But mostly it's just, we both are used in deriving it. It's not actually secret sharing. It's the details of the KDF are in the white paper. It's a little bit messy because we left a hole for where we wanted secret sharing to go in. So after you do some key derivation stuff on both, they actually get XOR'd, and then some stuff after that. So yes, it really is two secret key derivation, not one key for one thing and another key for the other. Okay, whoever has the microphone should talk.
Is there a way to have more than one team owner, or can everyone in a
Yes.
team be an owner?
Yes, and this is something that we encourage, is specifically this, is if you have more than one team owner, you've got more than one person who's capable of doing recoveries. If, let's say, a team owner gets, hit by a bus or loses their account key or forgets their master password. So it's actually, for teams, it's another one of these quests. We try to say, set up another owner organizer. In our original beta, we actually had a more complicated set of roles. So we had what was called the recovery group, but we just merged that with owner and organizer because it was confusing people. But underlyingly, we actually have the ability to specify a recovery group, which is a group of individuals who are the ones who are getting these vault keys and have the power to initiate recovery. So there's more granularity under the hood than is actually exposed to the users.
So when you sign a new team member, is that all done on excuse me, is that all done on the client computer of the team owner?
So the invitation for a new team member is constructed by the client of the team owner. The email notification goes through us, but the invitation URL is constructed by the client. And I suspect I'm not actually answering your actual question.
No, so basically you said that you encrypt the master key with the new team members publicly. Right? So where do you do that? Do you do that on your server? Do you do that on the client of the owner?
Oh, sorry. So once you confirm somebody who's joined in, right. So when an owner confirms somebody who joins in, what they are doing on their client is encrypting, let's say, the shared vault key to the public key of the new member.
And follow up to that, the reason I kind of led into it is, have you considered open sourcing at least that part of the code to be audited to make sure that sort of security happens?
Repeat the question.
Oh, okay. So then the follow-up is have we considered open sourcing that code so that people can actually see that this really is happening client side? Considered it, yes. We haven't done it yet. I'm sure we've got all these normal end user license things that say, oh, reverse engineering is bad. Just, reverse engineer it, check it out.
Okay. So Jeff, of course, is going to be around here, and there's also Jesse. If you anybody, and well, everybody should say hi to Jesse. That's my opinion. So once again, thank you, Jeff. And